Hello everyone and welcome back to Step by Step Electronic by Techno20. Today in this section we'll try to take a look at a conception program what make electronic designs, and this Proteus. I find it really so complex and so complete to make your electronic schematics. So for this one will be a um, practical video more than just explaining and presenting. So we'll be seeing this program for how it looks, the windows and the menus, how to access to device panel to get your devices and parts, the wiring and editing, and how how it works, simulation, and like in usual we will have a bit of an exercise, and maybe um, if you are interested, send me your designs, and maybe for the next chapter we will use the design what like the best one. Let's get started. So it's here the picture of the panel, and we will be using the circuit what was in our last evaluation, and to see how will work. Stay tuned. So here we are in Proteus, and so here we have file icons, paint, and all of this. Here is the view toolbar, here is the edit toolbar, and here is for copying blocks, rotating, all of this part here is for to access the part menu, and here to like configuration and to make your own device if you can, but it's more engineering tools. And this part is for the routing settings. In the left here we have selection and even the part list and labels, but for all of this maybe we'll mostly need this one to get some labels input and the power and the ground, and this one for virtual instrument for like oscilloscope and terminal, virtual terminal to check for example serial communication, and we will be seeing most of them in the future. So as we say, we'll start with the simple circuit what we saw it in the last chapter, what was in the evaluation. So let's go to pick the pieces. We'll be needing for the entry ABC, we will present them by switches. So switch will be this one. Just double click it to add it to the device list. And not gate. The same double click. And for 3 input will give us all of this. We'll choose this one, and we have also OR that will be 4 inputs, which will be this one here. We'll take resistance and a LED. This one, and that's all what we need for the moment. If we need something else, we'll come back again. Okay, now let's put our things. So the entries will be, this is to rotate your the device. You can put it how you want. This one will be edit property, will be the entry A, N, will be this one, will be the entry B, okay, and this one will be the entry C. Okay, now we have the knot. Put it down here. One here, one here, and one here. So the OR, sorry, the AND gate. We need 4, 1, 2, trying to make them 3 and 4, and in the end we need the OR 4 entries here in the middle, and will be resistor here, and LED. For the diode LED, we need a resistance between 220 ohm and 470. It's the interval for the LED to can work, because the LED mostly need between 2.7 and 3.5 volt. From 5. Okay, to wire it is just to, you see here, to make a zoom, Okay, you see we have like a red dot on the extremity. You just need to click there and to take the pen and enter the next point. Also from here. And so, okay, let's take a look again at our schematics. So the last one will be A and B. Let's see. A, B. Excuse me for that. And C here. Okay. This one here. This one here. This one. Huh. Ready to change position. Just right click on this one to access the menu. Okay. Alright, the next one will be see this one, and the next will be simple. And here, don't worry, it doesn't connect here. It connects only when you show the junction like this. This one will be simple. Not B and A and B. C, B and not A. Okay, as we say here, we need to change the value of the resistance. We take 220. This is how you want how the piece how the device is available for you to buy. Just it's between 220 and 470 as a value. Okay, and now we need the ground here and the power. Let's come back at the full sheet. Okay, here, here, and here. Okay, now almost our schematic is done, but let's run a simulation to see what will happen now. What is the difference between just a schematic in test or something and in the simulation? Okay, run it. If you make your equation right, normally should be when all of those are state 1. This one should be like it up. 1, 1 and 1. And here it is. See? So this one is a success. Okay, let's see what else we have here. So this one should be 0 here, that means is not active, and this 2 are active, yeah. But here is not lighting up. Why? If you look with me here, you see this dot high here, it's gray, and this one is blue. Blue means 0 and red means 1. And why is that is gray? Gray means nothing. It's like air. So we cannot continue this simulation because we need to add some other circuit to can make always or 1 or 0 always here, because when all are open like this, you see, it's just air, it's nothing. So we'll stop it here, and what we need to take the resistance, okay, for each one. Okay, 1 second to make some space. Just select all and drag it a bit down. Escape. Okay, resistance, as we say. One here. Here. And one here. Okay, we'll connect it to this level. And all of those will connect them to the ground, because the ground is 0. Okay, this one, this one, and also is for security purposes, because when we close this switch here, will be current circuit if we don't have something active to can avoid like yeah, short circuit or something. Okay, now let's run it again, and as you see here, it's all 0 0 0, yeah. And also here we have 0 1 1 because it's inverse 0. Okay, let's try again the combination what we saw here. So those two should be, this one should be open because it's not, and those two should be active. So as we see here, but before, because we don't have something to say here by default, so it will be air, it will be nothing. So this is our first schematic. I hope you enjoy it and you find it helpful. Like and subscribe, and will be a small exercise to make it for maybe how we say in the beginning. The best schematic will be chosen as example to make the next chapter. See you later and have a good day.